Right. So, hello everyone. Good evening. For today, we are going to talk about physics, all about vector and scalar quantities, introduction to kinematics, and Hooke's law under dynamics. So, let's start off with vector and scalar quantities. So, what is vector and scalar? What are their differences? So, for scalar, it has magnitude. Magnitude in physics is the numerical value of something, right? And in vector, it has both magnitude and direction, meaning not only does it have the numerical value, but it also tells us what direction the object is going. So it can either be north, south, east, or west, right? So the examples in scalar is distance. So let's say we have a car traveling 30 miles. So it doesn't tell us what direction that car is traveling. And the counterpart of distance in vector is displacement. So I mean, instead of just saying the car is traveling 30 miles, if you're talking about displacement, you're going to say that the car is traveling 30 miles east. So it also states the direction where the object or the car is leading to. Okay. So next naman nun is speed. And speed in scalar is just, let's say the car is traveling 30 miles per hour, right? And the counterpart of speed in vector is velocity. Velocity tells us how fast the object is going and the direction where it's uh, trying to go to. So instead of just saying the car is traveling 30 miles per hour, you're going to say the car is traveling 30 miles per hour east. So to put it in simple words, anything or any quantity that you can apply direction to, that is also considered as a vector na. But if you can't apply direction to it, it's considered as scalar. So like mass, we have you can't apply direction to it because you're just weighing the object. In temperature, you're just stating how hot or cold an object or a place is. So you can't um, apply direction to it. And in volume, you're just stating um, an- how much of space an object can take up. And here naman in vector, we have force. So let's say we have 300 newtons of force exerted in a ball, and if you can also apply direction to it, because if you apply force to something, it moves, right? Force is a push and pull, so it has direction. And in acceleration, acceleration is tells you how fast your velocity is changing. So let's say we have a car and a truck. Both can reach 0 to let's say 60 miles per hour. But the car can reach um, that speed. Sorry, there's someone in the door. Okay, so the car can reach that speed more faster than the truck. Okay, so you can say that the car has a greater acceleration than the truck. Right? So that's the logic behind acceleration. And you can also apply direction to that. So let's say the car accelerates to the north, to the south, or the east or west. All right. So that's the difference between vector and scalar quantities. So wala pa tayong computations in vector and scalar kasi we're just talking about quantities, not problem solving yet. Okay, so here you can describe a vector quantity in different ways. So here, number one, we have 100 newtons of force at a 30-degree angle. So you can express a vector by stating its magnitude and direction. Our force being the magnitude and the angle being our direction. So you can also express it graphically, as you can see here in number two. We just graphed what is in number one. So that's a force of 100 newtons at a 30-degree angle. Okay, and number 3 naman, here we expressed its components, right? So we have the x component being 30 newtons and the y component being 60 newtons. So we're going to travel 30 newtons to the right since our x component is positive, and 60 newtons up since our y component is positive as well. Okay, and the hypotenuse of the right triangle is the actual vector. Meaning this long side, kasi hypotenuse is the longest side of a right triangle, di ba? So the hypotenuse of the right triangle is the actual vector. So dito yung right triangle, di ba? So ayan. So this is the actual vector. Okay? So paano naman pag isa sa components mo is negative? So you're gonna travel naman dito to the left since our x component is negative 40. And you're still gonna go up since your y component is still positive. So that's what your graph is gonna look like. Okay? And number 5 naman, we have 200 newtons of force at a 225 degree angle. So in order for you to do that, you just have to measure the whole coordinate plane. So this is 0, this is 90, this is 180, and this is 270. How did we know that? Because every quadrant is at a 90-degree angle. So if you add that all, you're going to get a total of 360 degrees. Okay, so we're just going to estimate where is that 225 degrees, and it's in this quadrant. So this is our vector at 225 degrees. Okay, so these are the components of a right triangle showing our vector. So this red line, or the hypotenuse, is the actual vector. This is the angle theta. Dapat ito nasa loob, pero di siya ma-align. So, dyan siya sa loob. This is the angle theta. And this is the x component and the y component. So if you're looking for the components, you are going to use one of these formulas. So this is Fy. If you're looking for the y component, you're going to use this. Fy is equals to f times sin theta. If you're looking for the x component, you're going to use f times cosine theta. And if you're looking for the angle theta, which is the angle between 0 and 90, most of the time it's an acute angle. So ayan. So you're going to use the inverse tangent, close up in parentheses, Fy over Fx. Okay? Then if you're looking for the vector or the hypotenuse or the value of f, you're going to use sorry guys, may pumasok. Okay, so as I was saying, if you're gonna if you're gonna find the value of f, you're gonna use this, derived from the Pythagorean theorem. This is the square root of fx squared plus fy squared. All right, so next is, let's move on to the introduction to kinematics. So unlike ay, mamaya pa pala yan. So, in kinematics, we have a lot of different formulas. So, ito lang yung mga iba na most of the time na ginagamit. So, under constant speed, we have d is equals to vt, where v can either represent velocity or speed. Pag v represents speed, d will represent distance. Kasi speed and distance is under scalar. So pag v represents velocity naman, d will represent displacement. Okay? So pag ganon, pag displacement, displacement can either be at the x-axis or at the y-axis. So you're gonna use this too if you're gonna find that. So d is equals to x final minus x initial, or d is equals to y final minus y initial. Ano pong part yung i-repeat? Constant speed, all right. So d is equals to vt, where v can either be velocity or speed. Speed, if v represents speed, d will represent distance. If v represents velocity, ba't wala kayong marinig? Hold on. So, ayun nga. So if d represents displacement, it can either be at the x-axis or at the y-axis. So you're gonna use these two formulas. And, oops, may nag-admit. Okay, and if you're going to find the x final, you're gonna use this formula. So it's x final minus, x final is equals to x initial plus vt. And papakita ko sa inyo kung paano siya gamitin mamaya, right? I'm just discussing or familiarizing you guys to the some of the formulas in kinematics, right? So under constant acceleration naman, we have these formulas. V final is equals to V initial plus AT. V final squared is equals to V initial squared plus 2AD, and D is equals to 1/2, close up in parentheses, V initial plus V final times T, and D is equals to V initial times T plus 1/2 AT squared, right? So, mamaya papakita ko sa inyo kung paano siya gamitin, right? So, in units, the units that we commonly use in kinematics are these. For speed, we use meter per second. Acceleration, we use meter per second squared. For distance, displacement, and position, we use meter. And for time, we use s, or seconds. All right? So let's go to problem solving. So a car accelerates from an initial velocity of 26 meters per second east at a rate of 4.25 meter per second squared for 8 seconds. So part A, what is the final velocity of the car? So we're looking for the final velocity. We're going to use this formula over here under constant speed over here. We're looking for the final velocity. Okay, so let's list down first what we know. So we know that our initial velocity is 26 meters per second, and our acceleration is 4.25 meters per second squared, and our time is 8 seconds. And what is the final velocity? So we're going to use this formula. V final is equals to V initial plus AT. So you're just going to plug all of those values in, and you're going to get 60 meters per second. Okay? So, ganun lang siya kadali. And part B, how far does it travel during this time period? So, we're looking for the distance. Okay? So, D is equals to 1/2. Oops, may nagamit. 1/2 goes up in parentheses, V initial plus V final. Dapat subscript yun, pero di ko na siya na. But yeah, times T. So, you're just gonna plug that in, and you're gonna get that. So 26 plus 60 is equals to 86. If you divide it by 2, you're gonna get 43, and you're just gonna multiply that by 8, and you're gonna get 344 meters. Alright? So ganun na siya kadali if ganyan lang yung problem. But I have a longer problem here. Yan. So let's discuss this. So an object is currently 800 meters east from a building traveling at a constant speed of 24 meters per second due west. All right. So part A, how far will the object travel in 15 seconds? So distance pa rin yung hinahanap natin dito. So let me explain this illustration. This is the building, and this is the object at 800 meters traveling at 24 meters per second. Okay, so we're gonna find out how far will the object travel in 15 seconds, right? So we're gonna use this formula for distance. D is equals to Vt, and our V, the value of our speed is 24 meters per second, and our time is 15 seconds. So you're just gonna multiply that, and you're gonna get 360 meters. So that's how far the object will travel under 15 seconds. All right, so letter B or part B, what is the position of the object relative to the building? So after traveling for 15 seconds, what will be the position of the object? So there are two ways that you can do that. You can subtract the initial position of the object, which is 800 meters, and the distance, which is 360 meters, and you're gonna get 440 meters. But if your professor or your teacher asks you to show a solution, this is what you're gonna do. So first step is you're gonna list down everything that you know. We know that the time is 15 seconds and our speed or velocity is negative 24. So bakit siya naging negative? It's because the object is traveling west. So negative siya. Diba pag west or south, negative. Pag north or east, positive. Okay? Kaya siya naging negative. Alright? So, sorry. So, yung x initial naman natin is 800 meters, yung initial position. And what is our final position? So, you're going to use this formula. X final is equals to x initial plus vt. X initial being 800, our v is negative 24, and our time is 15. So, negative 24 times 15 is negative 360. So 800 minus 360 is 440 meters. Okay? So, ayan yung proper way of computing it. But if you want to do it the easy way, subtract mo lang siya. So, next naman, part C. After traveling at a constant speed for 15 seconds, the object begins to accelerate at 3.6 meter per second square, due west for 85 seconds. Now, the question is, what is the final position and displacement of the object? So first, let's talk about the final position of the object. All right, so we're looking for the final position here, and we'll list down everything that we know. Our acceleration is negative 3.6 because it's still traveling west. All right, and our time is now 85 seconds kasi tapos na tayo sa 15 seconds. Our initial velocity is negative 24 pa din, and our initial position is 440 meters. Okay, so you're going to use this formula. X final is equals to x initial plus v initial times t plus 1/2 at squared. Alright, so i-plug mo lang yung mga values mo and you're gonna get this answer. So paano ko yung ginawa? Ayan, so dito muna tayo sa part na to. So negative 24 times 85 is negative 2040. And if you're gonna add this to 440, you're gonna get negative 1,600. And so yung answer na tong part na to is negative 1,600. And dito naman tayo sa part na to, so 85 squared is equals to 7,000. Ate, bakit dun sa... hindi naman lang. Because we're talking about distance here. Okay? Dito, hindi pa siya considered as a vector. We considered the distance as a scalar pa lang here in letter A. But B, C, and D, we considered it already as a vector. Vector na siya sa B, C, and D. Okay? So, dito naman tayo. Nasaan ako? Yan. So, we got 7,225 and we're gonna multiply that to negative 3.6 and we're gonna get negative 26,010. And if you're gonna divide that by 2, you're gonna get negative 13,005. Yes po. Okay. So, if you're gonna subtract that both, paano kapag pupunta siya sa north? Wait, may nag-ano. Magiging, yes! Kasi pag north and east, di ba positive siya? If you're gonna uh, make your yun, ang tawag doon, coordinate plane as your reference, di ba pag north and east, positive. Tapos pag west and south, negative. Eh dito, the object is traveling west. Kaya naging negative siya. Okay? So, back to letter C. So, negative 1,600 minus 13,005 is equals to negative 14,605. So, ganun yung process niya. Since sa sets, hindi pwedeng mag-calcu, kaya I tried my best na hindi gumamit ng calcu. Okay. So, ayan na yung answer. Yun na yung final position ng object natin. So, bakit siya naging negative? Meaning, yung object, nakalagpas na siya sa building. So, ibig sabihin, nasa west side na siya ng building. So, that's why the final position of the object is negative na. Kasi nakalagpas na siya sa building. If it's at the east of the building or the east side of the building, positive pa rin yan. Pero, since nasa west side na siya, naging negative na yung position niya. Okay? So, dito naman tayo. What is the displacement of the object? Okay? So, dito naman, you're gonna use this formula. D is equals to x final minus x initial. So, x final natin is negative 14,605 minus 440. You're gonna get negative 15,045 meters. So, ayan na yung displacement ng object natin. Alright? So, letter D, the last one. What is the final velocity of the object? Okay? So, you're gonna use this formula, Vx squared is equals to V initial squared plus 2AD. So, you're just gonna plug everything that you know. So, ito yung procedure na ginawa ko. Negative 24 squared is equals to 576. Tapos, dito naman sa side na to, negative 3.6 times negative 15,045 is equals to 54,162. And if you're going to multiply that by 2, you're going to get 108,324. Kaya siya naging ganyan. So you're just going to add that up and you're going to get 108,900. Para mawala yung squared dito sa VF squared, you're going to square them both sides and you're going to get 330 meter per second. Now, bakit siya naging negative? It's because if you square any number, as you can see here, if you square any number, it can either be positive or negative. Kasi if you're gonna plug in siguro negative 5 dito, you're still going to get 25, di ba? Ganun yung ano nun. Kasi di ba ang rule sa multiplication, pag same yung sign, your answer will become positive pa din. So, yun. Kaya, be careful in these kind of problems kasi you have to ask yourself if your answer should be negative or positive. Bakit naging negative dito? Is because the object is still traveling west. It's still in the west side of the building. Kaya, ano pa rin siya? Negative pa rin siya. Hindi siya naging positive. Alright? So, let's go in our last topic for today is Hooke's law under dynamics. So this is the basic concept of Hooke's law. So I have here a horizontal spring. Sorry for the bad drawing. Sorry. So I stretch that spring and we'll call that force. We'll call the force that stretched it as Fp. And that force is positive. And also the displacement of that spring is also positive. And also, we'll label the distance traveled by the spring when we stretched it as x. That's why one of the formulas for dynamics or being Hooke's law is Fp is equals to Kx, wherein K is equals to the spring constant. So I'll talk about spring constant later on. So yeah, and we also have here Fs or the restoring force. Restoring force comes in when you let go of the spring. So, di ba, yung spring, turns back into its original form and length. That force is called the restoring force or Fs. And that force is negative kasi pa-west naman siya. Since this is a horizontal spring, west and east lang tayo. So, ayan. Kaya naging negative yung Fs. That's why we also have this formula, Fs is equals to negative k times x, wherein our k is negative. Okay? So let's put that in problem solving. Okay? So number 1, a force of 200 newtons stretches a spring by 4 meters. What is the value of the spring constant? Okay, so we're going to derive a formula from the original formula, which is this. So we're going to find the spring constant. So K is equals to Ft, wherein our force is 200 newtons and our x, or our distance, is 4 meters. So you're just going to divide that both and you're going to get 50 newtons per meter. Sorry. So our logic behind that is for every 50 meters, you can stretch that spring by 1 meter. Kaya try nyo i-multiply to by 4. Ang magiging sagot nyo dyan is 200. That's why you need a total of 200 newtons of force to stretch that spring by 4 meters. So ayun yung logic behind that. So let's say I have spring A and spring B. Spring A has a spring constant of, spring A has a spring constant of 50 newtons per meter. And spring B has a spring constant of 300 newton per meter. So which spring has a higher stiffness? Or which spring mas mahirap na i-stretch? Which spring is stronger? Is it spring A or spring B? Yes, it's spring B because for every 1 meter in spring B, you need a total of 300 newtons. So unlike pag spring A, 50 newtons per meter lang ang kailangan mo. So as you can see here, as the spring constant goes up, the stiffness of the spring also goes up. So ayun yung logic behind Hooke's law. Alright? So since 5 minutes na lang tayo, yan. So try nyo tong answeran in 2 minutes, under 2 minutes. The spring constant is 300 newtons per meter. What force is required to stretch a spring by 45 centimeters? Okay, 2 minutes. Try nyo siyang sagutan. Okay na guys. Meron ako kasagot. Since 4 minutes na lang tayo, I'll reveal the answer na. So this is how you solve this problem. So our default, yung original na formula natin is already like this. Kaya hindi mo na kailangan mag-derive ng any other formula. So Fp is equals to Kx, wherein our spring constant is 300 newtons over meters, diba? Newton per meter. Then yung yung unit na ginagamit sa Hooke's law is mostly meters. So kailangan natin tong i-convert into meters. So you just need to divide it by 100 and you're gonna get 0.45 meters. Or you can also move 2 places. Yeah, 2 places to the left. 2 decimal places to the left, and you're going to get 0.45 meters. So in order for you to cancel out the meter unit, you need to, yan, ganyan gagawin nyo. And you're going to cancel out meter, and you're going to just multiply this both, and you're going to get 135 newtons. Yay, may nakakuha. Okay, so last na example and yung last slide natin. Yeah, cross multiply. So, yan. A force of 250 newtons is required to stretch a spring by 24 centimeters. How far can a force of 900 newtons stretch it? So we're looking for the distance. Okay. So first we're going to look for the spring constant. So you're gonna get the force of 250 newtons and 24 centimeters. So convert mo siya into meters, which is 0.24 meters, and you're gonna get 1,041.6 repeated. Or you're gonna, pwede mo siyang i-round off into 7. Okay, so walang problema dun. And now na meron na tayong spring constant, you can now solve for x. So x is equals to F over K, wherein F is 900 newtons and K is 1,041.6 repeated. And if you're going to divide that, you're going to get 0.864 meters. And if you want to convert that to centimeters, you're going to just move 2 decimal places to the right, and you're going to get 86.4 centimeters. Okay, so mas madali yung Hooke's law kaysa sa kinematics kasi sobrang daming formulas na kailangan mong malaman doon. Dito, dalawa lang. So, ayan yung pinakaiba ng Hooke's law and like kinematics. Alright? So, yung mga yan. Yung mga dati pang nag-a-attend, usually meron tayong mga quiz, di ba? But today, or this week, hindi tayo mag-quiz after this lesson. Because I want to try and make the quiz in Google Forms. Kasi doon mas matatrack ko yung mga yung mga scores nyo, and help you guys, or yung tulungan yung mga iba na hindi masyadong nakakaintindi sa lesson, or may hindi naiintindihan, or yung mga hindi nakaka-join sa Zoom meeting. So I want to help you guys as much as I can. So I'll try and make the quiz through Google Forms. So I'll just send the link sa GC natin, and you just have to fill in that form, and that's it. You're gonna get your score and siguro that same day. I'm gonna send the link tomorrow after the Thursday session. So ayun. The submission of that will be on Friday. Anytime you can submit it on Friday, basta wag kayong lumipas hanggang Saturday. Okay, so no pressure. You take your time, and ayun. For next meeting naman, next week, we are going to talk about biology, about organic and inorganic compounds, life functions, and cells. Okay, so that's it for today. Thank you so much for joining us in our Zoom meeting, and I hope to see you guys next week. Sabihin ko sa GC kasi na tayo patapos na yung meeting. So I'll recap na lang in the GC, alright? So thank you so much for watching. For